Hi everyone. I'll just begin with a very quick summary of our project. So as you can see from the second page of our slides, that we have analyzed the US air quality data across 4 key dimensions: geography, demographics, pollutant types, and also the time trends. From these, we have identified 2 major insights. First, Western states, especially California, tend to have the worst air quality than others. Second, ozone and the PM2.5 are the dominant pollutants, making up the majority of the unhealthy air days. These two factors, location and the pollutant type, play a very huge role in shaping the regional air quality patterns. And next, we have get some few more key takeaways. First, around 30% of all observation days fall under the good AQI category, so that's the good news. However, about 30% of the days still show unhealthy air, especially during summer or in specific cities. Notably, Independence Day records the worst AQI level for the year, likely due to the fireworks. And finally, we observed that higher density cities tend to have the poor air quality, although there are exceptions. So population density matters, but so does the urban planning and the pollution controls.
And in this part, we'll start with a look at how air quality varies across different US states. As we can see from the bar chart, Western states like California stand out with not only high average AQI levels, but also the highest proportion of unhealthy days. California alone accounts for over 30% of total unhealthy days nationwide. In contrast, most other states like Alabama and Colorado maintain a higher proportion of good air quality days, shown in light green on the stacked bar chart. This regional disparity points to how industrialization and population density can strongly affect air quality. For example, Pennsylvania, a highly populated and industrialized state, also show elevated health risks. Next slide, please. Now let's shift to the city level, but we see a similar story. The pie chart shows that nearly 70% of city level AQI ratings fall into the good category, which is a positive national trend overall. However, hazardous and unhealthy for sensitive groups days, though relatively rare, still appear in specific locations. For instance, cities in California and Alaska report the majority of these extreme ratings. On the right-hand map, you can clearly see clusters of poor air quality, especially in Southern California and urban industrial zones. These hotspots align with the regional disparities we just discussed, reinforcing the importance of local population control. So overall, while most of the US maintains decent air quality, there are clear geographic patterns where risks are concentrated, especially in large or industrialized urban areas. And my teammate will continue.
So, on this slide, we analyze how population density is related to the air quality measured by average AQI across US city. So in the top chart, you can see a scatter plot of all cities in our data set. The horizontal axis show average population density and the vertical axis show average AQI. So each dot represents a city and the size of the circle reflects its population. So the trend line clearly goes upward. This means that in general, cities with higher population density tend to have worse air quality. The logic is simple. So more people means more traffic, more buildings, and more population. So however, we also found some exception, which we show in the bottom chart. This similar chart focuses on 6 specific cities and they tell a more interesting story. So for example, New York, San Francisco, and Boston all have high population density, but their AQI levels are relatively low. So this shows that it's possible to be a crowded city and still have clear air. This cities like benefits from good public transportation, strict environmental policies, and fewer polluting industries. So on the other hand, Riverside, Fresno, and Los Angeles have high AQI levels, even though their population density is not the highest. In fact, Riverside has one of the worst AQI values in the city. This may be because of the geography, heavy car use, and weak population control. So what does this mean? Our conclusion for this is the population density does affect air quality, but it's not the only factor. Smart city design, environmental laws, and transportation system also play a big role. So next.
Now let us shift our focus to the specific pollutants that drive poor air quality and how their patterns change over the year. Starting with the chart on the left, ozone stands out as the most dominant primary pollutant. It accounts for around 54% of AQI records and has the highest average AQI value at 52, meaning it not only appears frequently, but also tends to cause more air pollutant when it does. PM2.5 is less common, but still very dangerous. It is associated with a high average AQI and can pose significant health risks, especially for sensitive groups like children, the elderly, and people with respiratory conditions. Meanwhile, pollutants like NO2 and CO and PM10 occur less than and show relatively lower AQI values, but they still contribute to localized pollution spikes, especially during specific events. Moving on to the monthly and distribution pattern. Looking at the monthly trend, we can clearly see that both ozone and PM2.5 level peak during the summer months, particularly from June to August. This makes sense, since ozone formation is triggered by sunlight and heat, and PM2.5 often increase due to wildfires or industrial activity in hotter months. By contrast, pollutants like CO and NO2 maintain more stable level year-round, indicating more consistent emission sources, such as traffic. Finally, if we look at the scatter plot for AQI distribution, it shows that air pollution is mainly caused by PM10, PM2.5, and ozone, as they have generally higher AQI value and denser distribution. In contrast, NO2 and CO have lower AQI value, indicating a smaller impact on overall air quality. Furthermore, PM10 and PM2.5 is inhalable particles with widespread sources and strong persistent in air, making them key contributors to the health issues and long-term pollution.
Well, in this part, I will briefly walk you through some key insight how time and special occasions affect the air quality in the US. Let's start with the monthly data. As you can see from the line chart, the air quality is at its worst in the summer, especially in June, July, and August, where the AQI goes above the boundary line. Why? Well, in summer, people travel more, use more air conditioning, and wildfires are more common, all of which can increase pollution. On the other hand, in the winter months like December and January, the AQI is much lower. So overall, pollution peaks in summer and drops in winter. Next, looking at the seasonal changes over the years, we analyzed the data from 2002 to 2018. We saw the same pattern, Q3 or the third quarter, which includes those hot summer months. But most importantly, if we look at the yearly changes, we see a clear downward trend from 2002 to around 2018. The colors in the heat map slowly fade from darker to lighter, especially in quarter 2 and quarter 3, which means the air quality is gradually improving over the years. This could be the result of stronger environmental regulations, clear technology, or better awareness among the public. Now let's talk about the holidays. This might surprise you. Independence Day has the highest pollution level, even worse than the regular days. This could be because of the firework, the barbecues, and a lot of driving. In contrast, Christmas, New Year, and Thanksgiving all have much better air quality, probably because people stay home more and travel less. So to wrap up, summer months and celebrations like Independence Days present pollution spikes, while colder season and a quieter holiday offer some environmental release. My teammates will continue the last part.
So, based on our findings, we propose 2 sets of the recommendation. For the public, we stress 3 simple actions. First, stay air aware during the summer, especially in July and August. Second, protect vulnerable groups like kids, the elderly, or people with asthma on high AQI days. And lastly, during the holidays like July 4th, trying to celebrate responsibly and reduce outdoor burning. And on the policy side, we believe that it's important to strengthen air pollution controls in summer when AQI peaks, and we should target major pollutants, especially ozone and PM 2.5, with stricter emission policies. And finally, urban planning should be used as a long-term tool, supporting cleaner transportation and separating residential areas from the industrial ones. Together, these steps can help create a healthier and more breathable future. And that's all for our projects. Thanks for listening, and this page is our reference. So we hope this give you a very clear picture of the US air quality patterns and the solutions. Thank you for listening.